Hi everybody, welcome to my second video on axial bars. In this video I'm going to be talking about a simplistic axial bar. If you want to check out more complicated axial bars, check out my videos number 3 to number 10. Those will give you some more complicated examples. Alright, so let's just get going here. So let's say we have an axial bar. It looks like this. And we are pulling on it with a force P. Alright, so the first thing we want to do is analyze what's going on in here. Alright, so in order to analyze what's going on, like I said previously, we need to make a cut. So these little arrows just mean which way I'm going to look. Alright, so when I draw my free body diagram, that's the section I'm going to draw. Alright, so FBD, free body diagram, looks like this. Alright, there we go. Label our directions. Y, X, positive. So I'll have P here. And now we have an internal reaction, N. Alright. This one's pretty straightforward. I think I've even done it before in a previous video. So we do the sum of all the forces, the x equal to 0, and we find P is equal to N. Alright, there we go. Bang. Now, what's a very useful thing to do is to graph the internal force in the bar. Alright? So what I'm going to try to do on my videos is to draw the picture and then along the same line, somewhere down the page, draw the internal force. Graph. Alright, so we're going to call it N. Make a nice little circle. Okay. And this is about where it ends right here, right? There we go. And it has a force, N equals P, for the whole duration of the bar. Just like that, you call it all in, and it has a magnitude P. Alright, so that means anywhere you go in this bar, you're going to find an internal reaction of an amount P. So however much you pull here, that's how much it's going to be internally. Alright, let's move into the second example here. We have a similar type of bar situation. And a little bit longer. We have a load here of P again. And now we also have another load here of 2P. Alright. And of course we're going to need some distances here to make any sense of this. Alright, so this length here is L. This length here is L by 2. Alright, so we've drawn our clear picture. Now we need to move into free body diagrams. So in order to find the internal forces in here, we're going to need to make some cuts. Now here's where we got to start. Being careful, because the internal force in this section from here to here is not going to be the same as the internal force between here and here. Alright, so in order to find out what it is in here and what it is over here, we need to make two separate cuts. The first one, we'll just keep looking this way. Second one, we'll go this way. Alright, so we'll call this 1 and 2. There we go. Alright, so let's do a free body diagram of section 1. Looks like this. We have an applied load of P on this piece, right? Because that's from over here. And we also have an internal reaction here, this way, N. Now we've got to kind of give this some, labels. So let's just call, since this we call this 1, we'll just call this N1, and this piece here later on, and there we'll call N2. Alright, so don't forget some of the forces, the x equal to 0, N1 equals P. There we go. Alright, there we go. That was actually the same as it was over here. So the next step is what's different. So the second free body diagram for the second cut, of course it's a bigger piece, so let's just kind of draw it bigger here. All right. In this section, we have a load P and 2P, all right? And of course, then we're going to have a reaction here, N2. Now, we could have made this cut here, any point from here, all the way to where this load is like applied. So basically, this length here could be an arbitrary distance, all right? So this N2 is going to be the same from here to here, and N1 is going to be the same from here to here, all right? So now, we just do it again here, sum of the forces, the x equals to 0 for equilibrium, P plus 2P minus N2 equals 0, so N2 equals 3P. Alright, there we go. So once again, we'll graph this. We'll graph it directly underneath here. It's a normal force graph, give it N. Out here. There we go. Alright, so in the first piece, in section 2, it's 3P. Alright, so it's up here somewhere. P, and then in segment 1 is only equal to P, so it jumps down to about a third of the height. Alright, there we go. So those are the two examples I got for you right now. So basically what we did, we took the bar, we cut it, did a nice free body diagram, some of the forces, then we graphed and internally. The second example, every time there was something new, we made a new cut. So the area was always the same. So, oh, here's something new, we made a cut. As soon as we hit the 2P, we need to make another cut. Because every time you change an external condition, the internal condition is going to change as well. Then we took a look at both freed up body diagrams of both pieces, found those internal forces, and then plotted them the same as we did in the first. Alright, hope this video helps you guys out. I'll see you in the next video.